Welcome back to another video. Today in this video I am going to show you how to design and simulate Common Gate Amplifier in Cadence Virtuoso. Open the terminal and type Virtuoso. Create a new library as usual. In File, New, and select Library. I am going to give name as Common Gate. Attach the GPDK90 library and click OK. Now go to File and create a new cell view and select your library. Now I will name it as CG Amplifier and click OK. Now the schematic editor window will open. Now we will browse the components by clicking I in the keyboard. From the GPDK90 library, we are gonna take a PMOS and NMOS transistors. Now from the analog lib, we need IDC, and for the magnitude of the IDC should be 100 microamperes, and place it on the schematic editor. Now connect the components with the wire. Connect the body terminals. Now we need to add pins, so we are gonna add VDD and V in, V bias and V in. Now we're gonna add output pins, which is a V out, and connect it to the V out terminal. We need to ground the body terminal of the NMOS and click on check and save. So we have no errors, so we are gonna create a symbol from create cell view from schematic and give the pin specifications. Bottom pin as V bias, and we're gonna remove VDD and V in from left pins. So our symbol has been created. Let's edit the symbol as CG amplifier, and instant name bring to symbol and keep it at the center of the symbol, and save the symbol. Create a new file, call it as CG amplifier test bench, and add the symbol which we have just created, and At the sources, go to analog lib and search for V sine and give the magnitude as DC voltage as 0, AC as 1 volt, and amplitude as 5 millivolts, and frequency 1 kilohertz. Now we need VDC, give the DC voltage as 2.5 volts and connect it to the V bias and VDD. Connect the sine wave source to the V in and extend the wire for the pin. Now we need a ground and connect to the all the sources. Now we need to add V out pin and V in pin. Now save the symbol, click on launch ADEL and analysis, choose analysis. For the transient analysis, give the stop time as 5 milliseconds and moderate. For the AC analysis, give the start time as 150 to 100 megahertz and click OK. Outputs to be plotted, select on the schematic input and output, then go to editor environment again and run the simulation. So we have here two responses, one is transient response and another is AC response of the common gate amplifier. Thank you.